In this lecture, we are going to study about the introduction to magnetism. This is Unit 5, Lecture 4. So here you can see a bar magnet having a north pole and a south pole, and we are having field lines around it. And very clearly it can be seen the field lines are from the north pole to the south pole, or they go away from the north pole and enter into the south pole. And the region around it is called as the field. Now, the region around a magnet in which it exerts force on other magnets or on other magnetic material is called a magnetic field. Magnetism arises from the magnetic dipole of magnetic materials. You see, what is magnetic dipole? You have a bar magnet having a north pole and a south pole. This is the magnetic length. 2L is taken as a magnetic length. Geometrical length is different. It is from the end to end to end. That is geometrical length. But here we are talking about the magnetic length taken as 2L. And the pole strength over here is small m. The magnitudes will be the same. North pole and the south pole. Okay. Now, a pair of magnetic poles of equal and opposite strength separated by a finite distance is called magnetic dipole. The magnitude of dipole moment is a product of pole strength m and the separation 2L between the poles. So capital M is equal to small m into 2L measured in ampere meter square. The direction of dipole moment is from south pole to north pole along the axis of the magnet. So this is the axis of the magnet and the direction is from south pole to the north pole. What is magnetic flux? In the diagram you can see these are the lines and this area is perpendicular to it. Maximum lines are passing, but in this case you can see almost no lines are passing and here intermediate number of lines are passing. Okay. So magnetic flux is defined as the number of magnetic field lines passing through a given closed surface. It provides the measurement of the total magnetic field that passes through a given surface area and measured in Weber. So in this diagram we have magnetic flux, okay, and here we have minimum flux. Next we can see what is magnetic induction or magnetic flux density. The number of field lines passing through unit area of cross section is called magnetic induction or magnetic flux density. B is equal to flux per area, which is equal to Weber per meter square or Tesla. Magnetic field intensity or strength at a point in the magnetic field is the force experienced by a unit north pole placed at that point, and units are ampere per meter. We have a general relationship B is equal to mu H, where mu is the permeability of the medium. Now, permeability is a material property which describes the ease with which the magnetic field lines can pass through the material and is measured units are Henry per meter. Next we can see what is intensity of magnetization. We know mu is equal to mu naught into mu r, where mu naught is the permeability of free space and mu r is the relative permeability. Mu naught is 4 pi into 10 to the power of minus 7 Henry per meter. The intensity of magnetization of a material is the magnetic moment per unit volume, when I is equal to m by v. The units are ampere per meter. Magnetic susceptibility of a material is the ratio of the intensity of magnetization produced in the material to the magnetic field intensity which produces the magnetization. That is given as I by H. It has no units. And also mu r is equal to 1 plus susceptibility. So in this lecture we have seen the various definitions that are related to magnetism, and we're using all these definitions in the future lectures for our derivations that are present.